Hi, everyone. Thanks for joining us for today's webinar, Unlocking DER Potential in Canada. I'm Evan Pivnik, Clean Energy Program Manager at Clean Energy Canada. If you don't know us, we're a think tank at the Centre for Dialogue at Simon Fraser University in Vancouver, BC. It's located on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh peoples. A couple of quick housekeeping items before we kick this off. First, if you have any technical questions, you can ask them through the Q&A icon at the bottom of your Zoom screen. My colleague, Kira Torrance, will be happy to provide support. Second, we'll be welcoming questions in the final 20 minutes or so of this webinar, which runs for an hour and 15 minutes. You are muted, so please do submit your questions through the Q&A icon and feel free to ask them at any time. We will be compiling them and putting them forward later. Finally, we'll circulate a recording of this webinar and a copy of the slides to all who've registered. Please feel free to share that widely. We'll also include a link to Clean Energy Canada's awesome newsletter, which you should absolutely be signed up for if you haven't already. We share a lot of good information through that. Turning to why we're all here today. If you're even a casual consumer of the media, you'll know that energy systems around the world, from what powers the vehicles we drive to how we heat our homes to what our industries run on, is changing at a pace and scale that's seldom been seen before. The rising demand for electricity and the electrification of our homes and economy is reshaping how we plan and build our electricity system. And few places are poised for greater transformation than the role that energy consumers can play. Previously, consumers played a more passive role in a centralized energy system. But with the surge in household adoption of electrified clean technologies, everything from water heaters to smart thermostats to EVs to heat pumps, households are increasingly a resource that can be harnessed to reduce energy consumption or shift it to lower demand peaks. These distributed energy resources can offer significant opportunities for grid operators and distributors to reduce infrastructure costs, to say nothing of the cost benefits and quality of life improvements that households themselves can seize. But this is only possible if we plan and build and operate our system in a way that keeps up with this transformation. So today we're going to be hearing from a great panel that will offer a global, continental, and national perspective on this issue. Our panelists include Constanza Iribarren, manager at Blue Nomi, Sanam Sergici, principal at the Brattle Group, and Alex Hill, a partner at Dunsky Energy and Climate Advisors. To kick things off, I'm going to be passing it off to my colleague, Catherine Jeffrey, who's policy advisor at Clean Energy Canada. We'll give everyone a bit of an introduction on this topic before we go to presentations from each of our panelists that showcase some of the recent work they've done looking at different opportunities that DERs can play in Canada and how we might go about unlocking those opportunities. Finally, we'll have a bit of a roundtable discussion before we open it up to the audience Q&A questions that you've been putting throughout. I will pass it off to Catherine at this point.
So hopefully you can all see that. I'm just going to give a really brief introduction to kind of how we see centering DERs and energy planning today at Clean Energy Canada and where we see big opportunities in the Canadian context, as well as a little bit of an overview on some of the work that we're doing right now. So here, in Canada right now for Clean Energy Canada, we have two big projects on DERs right now in Ontario and British Columbia. Obviously, those two provinces have really different market structures, so our projects are kind of calibrated to those different structures and the opportunities that we see there. In Ontario, we're working with Brattle to illustrate how DERs can be deployed by LDCs, so at the distribution level, to defer infrastructure upgrades, and we really want to assess the benefits of that approach. And then in BC, we're working with Dunsky to identify cost-effective and feasible DERs and look at, from the system as a whole level, how those DERs could reduce peak demand across the province. And you may hear a little bit about those projects as those presenters share with us. Across both of those projects, we're advocating for policy solutions that can help unlock DER potential and maximize the role that DERs can play in our grids. So I'm sure a lot of folks on the call have talked and heard a lot about how our electricity grid as a whole is evolving. We have historically, planned for a system that's sized to meet peak demand with centralized generation. And this can result in oversized and costly supply and a lot of backup generation to maintain reliability at those peak times. Now, what we're seeing is a shift towards more modern electricity planning, so where distributed energy resources can actually be used to shape peaks. Obviously, utility scale generation still has a key role to play there, but that can be coupled with distributed supply as well. And so reliability needs can actually be met in part using distributed energy resources as opposed to costly peaking systems. And really, at Clean Energy Canada, we see households and residential consumers playing a really key role here, in part because consumer-based energy technologies have been growing in popularity. Part of the reason for this is that households are keen to keep their electricity bills in check. And these DERs, if they're harnessed, can be leveraged to manage peaks, shift demand to align with generation, and overall lower system costs at the distribution and transmission levels. But the key here in terms of having the economies of scale that's needed is mass adoption. So mass adoption is going to be critical for scaling benefits. So getting technologies into households is going to be a really key priority to see this transition. We see then the DER value stack kind of operating across all three levels of our electricity systems, from the granular level of households themselves all the way up to looking at huge generation and transmission costs. So at the generation and transmission level, we can harness demand response, and we can shift load to follow variable generation. So that can result in reduced renewable energy curtailment as we get more variable renewable energy onto the grid. We can defer costly infrastructure upgrades, and overall, that's going to make the system more resilient, especially in the context of extreme weather events. On the local distribution system, similar kind of value in terms of aggregating consumer generation and demand response in the form of virtual power plants. And that too can allow local distributors to reduce infrastructure costs through deferral or avoidance of upgrades, improved grid reliability and resilience. And even if we are very innovative, it can open up new revenue streams for distributors as well. And then down at the household level, households are adopting consumer technologies like heat pumps, EV chargers, hot water heaters. All of these things can be harnessed and leveraged as distributed energy resources. And not only can this mean that customers can save money on their energy bills, but also a lot of these new technologies can improve the comfort of homes as well. So there's some qualitative benefits there, in addition to energy bill savings. So here at Clean Energy Canada, we see a DER-centric future state where governments are prioritizing DERs as an energy solution before looking at more costly options. Sorry, I think the slide's going back and forth there. We also want to see a situation where utilities and system planners are actually champions for household adoption in driving DER potential. So where they see this as a really great opportunity for the system as a whole. And in terms of energy planning, where energy forecasts can integrate virtual power plants as an essential resource. So instead of looking at a bulk demand curve and then subtracting demand response from that, really seeing virtual power plants as a much more flexible, sophisticated, sometimes even dispatchable resource that can be harnessed to meet peak needs. So I'll leave it there. I want to save most of our time for our panelists. But again, thank you so much, everyone, for being here, and really looking forward to today's conversation.
Thanks so much, Catherine. At this point, love to invite Constanza to share her screen and give us a presentation on the work they've done looking at Canada and its VPP readiness, both across provinces as well as how it stands with the rest of the world.
Yeah, thank you. So is the screen sharing working?
You've got it.
Great. So hello, everyone, and thank you for the invitation. Over the next 10 minutes, I'd like to share some insights from our work on the VPP Readiness Index. This is a framework that was designed to assess how ready different jurisdictions are to deploy VPP at scale. This was done with the support to integrate of Integrate to Zero and layer of Clean Energy Canada. This index was applied in 2024 to 12 countries, and most recently to the Canadian provinces. So I will start by sharing on why the VPP Readiness Index was created and the criteria behind it. Then on Canada results, to finish with insights on international peers and lessons learned. My name is Constanza Iribarren. I'm a manager at Blunomy, a strategy consultancy advancing energy and climate solutions. I am currently based in Sydney after having worked on similar topics in Singapore and France. So let's start with why we need a VPP Readiness Index, or why we created one. So if we consider that VPPs are solutions that can provide important support to the energy transition by orchestrating DER and reducing system costs, enabling flexibility, and delivering benefits, we wanted to find ways in which to ensure that the global uptake would happen. But to really realize those benefits in a market, things need to evolve. Policies, frameworks, infrastructure all need to align for VPPs to uptake at scale and allowed orchestration of DER. So we built a tool to compare different markets and highlight what's working, identify gaps. So the index is designed to support technology transfer by surfacing what are the leaders or best practices, help policymakers focus when cross-learning is needed, to also build broader sectoral awareness, and to give investors or solution providers a clearer picture of where the real opportunity lies. So to create the index, we asked ourselves the question, what are the elements that actually allow a VPP project to fly in a market? And this allows us to create a set of 5 criteria. First is the resource availability, because you need enough CERs to orchestrate in a jurisdiction to be able to control them, to be able to have VPP uptake. This can include rooftop solars, EVs, batteries, flexible loads, such as electric heating. Second, you need to have flexibility needs, because depending on how badly a jurisdiction needs the additional flexibility in the system, you can expect different drivers for the commercial case for VPPs. Usually the flexibility needs are linked to the variable renewable energy penetration, the load variability, and the dispatchable generation fleet a jurisdiction has. Then you have the market attractiveness, or how VPPs can make money. So depending on the power system structure, on the presence of accessible markets for VPPs, the case can change. Then you have the regulatory environment, or how technology agnostic the regulations are to allow DER uptake and VPP participation. And last but not least, you have the grid operations, because utilities should have strong enough CER or DER integration capabilities and smart meter penetration for VPP to uptake at scale. This index was developed with 2 objectives in mind, or 2 intentions, that it can be applied to many countries or jurisdictions, even provinces, including ones that don't have a lot of data availability, and its utility to ensure that the index gives accurate view on the country's or jurisdiction's readiness. So as mentioned, this methodology was applied to Canadian provinces in 2025, so the report was published recently. For this edition, the 3 territories in the north were excluded given their distinct nature in their grids. And so we applied this technology to 10 provinces and ranked them by maturity and generated insights. So let's go see the results. So what did we find? Is that the 10 provinces in Canada fall into 2 broad groups. You have the 3 high readiness provinces that are shown here, followed later with 7 moderate. No province was in the low readiness group. Leading the pack, you have Ontario, Alberta, and Nova Scotia. And what do they have in common? We believe it's mostly their market structure. So Ontario and Alberta are the only provinces with fully liberalized electricity markets, while Nova Scotia has a partially liberalized market. All of the 3 offer revenue and participation opportunities for VPP, even if limitations remain. And this market attractiveness score, combined with strong grid operations and smart meter deployment, is what sets the leaders apart. Then, when we look at the results across all provinces, and we try to find common points, we see that resource availability is a consistent strength throughout the Canadian provinces. This is mostly linked to the availability of electric heating to be leveraged as a flexible resource. On the other side, a criterion which we see often relatively low scores compared to other countries are the flexibility needs. Today, most provinces still rely heavily on dispatchable generation, hydro, gas, coal, which actually reduces the urgency for flexibility in the system. But this is set to change. With the surge of new variable renewables on the horizon, rising demand for electrification, flexibility needs are expected to grow, and provinces that build readiness now will be better positioned to respond and to seize the benefits that VPPs or that orchestrated DERs can provide. So, and if we see the results by criteria, we see that on resource availability, it's Nova Scotia and British Columbia that lead. Both have flexible DR capacity that is at 100% or exceeding 100% of the peak demand. That is an untapped potential that is there. And this is backed by dedicated roadmaps or support schemes in those provinces. Then, on the flexibility needs, Alberta has the highest ones, but this is still relatively low compared to other countries. On market attractiveness, Alberta has the most open power system with wholesale market and retail competition and DR participation across energy and ancillary services markets, though some minimum capacity thresholds and aggregation restrictions still remain as barriers. On the regulatory environment and grid operations, Ontario leads on both, with smart meter penetration above 95%, active third-party VPPs already operating, and strong consumer data frameworks like the Green Budget Initiative that has been deployed. But how does Canada stand compared to other international jurisdictions? And the picture is encouraging. Canadian provinces are broadly on par with international peers, trailing behind the leaders that are Australia, France, and the UK. But they're still ahead of several countries, and we also see there's some disparity on their position depending on the province, because they have very different characteristics and conditions at the moment. When we look at the top performers that are Australia, France, and UK internationally, we see that they pull ahead on market attractiveness. Actually, in jurisdictions like France and the UK, for example, VPP providers or aggregators can access capacity, ancillary services markets, and energy markets, creating a diverse revenue stream that not yet exists in Canada provinces. However, on top provinces for Canada, so Ontario, Alberta, Nova Scotia, they actually outperform the leaders on grid operations with higher smart meter penetration. If we see the other end of the spectrum and we compare lower scoring countries like Kenya, Indonesia, and Nigeria with provinces that are at the bottom, so Saskatchewan, Newfoundland, and Manitoba, we see that these provinces actually hold an edge on the resource availability and have better regulatory coverage. But both groups share some weaknesses still that we believe that would evolve with targeted reforms. There are no VPP roadmaps or targets, limited financial support, and low smart meter penetration. So when we did this assessment and tried to find international trends, we find four main trends that we can highlight. First is that countries are supporting CR adoption and integration, and this is a trend we've seen in most of the jurisdictions that we assessed. However, this CR support hasn't really translated into generalized VPP support. So there's untapped CR capacity in most of the countries that we assessed. This shows that there's an lack of adequate regulations and access to revenues that hinders VPPs, and this is a consistent barrier that we see in most of the countries assessed. And also that smart meter rollout remains insufficient. And we see that many of those things, as I mentioned, also apply to Canada. So after this assessment, we also generated 4 big blocks of learnings for Canada or priorities for the future. As mentioned, we see that a consistent strength through the assessment is that electric heating is a core VPP resource that would be available to leverage given the weather in Canada and electrification of heating. But for these to be leveraged as a flexible resource, the country needs to build VPP capabilities and be ready to address the rising flexibility needs that the country will have. For this, it's important to strengthen provincial policies and incentives for CR/DR adoption, and to create additional revenue streams for commercial VPPs to participate, to be able to increase the the readiness and the market attractiveness that we see in the provinces, that, as I mentioned, is one of the elements that lags behind when you compare to international peers. So this is the end of the snapshot I wanted to give on the VPP Readiness Index results for Canada and internationally. The reports have much more detail, so don't hesitate to download them and to contact me if you have any questions or you have any suggestion on how to apply this index further for international cooperation. Thank you.
Thanks so much, Constanza. We're going to go to Sanam next, who is going to be sharing some work that Brattle Group has been doing in Ontario, looking at the distribution opportunity. Brattle does all sorts of work on this, especially down in the US, but has been working in Ontario for a while on different pieces of this. So over to you, Sanam.
Thank you so much. Can you see my screen?
We sure can.
Excellent. Okay, well, hello everyone. It's great to be here and talking about one of my favorite subjects, distributed energy resources. As Evan mentioned, we've been doing a lot of work on this subject in North America and elsewhere. So what I'll try to do today is to give you a little bit of a perspective on what's been happening in the United States, and then quickly switch over to some of the developments in Ontario. I've been doing a lot of work in Ontario, working with the ISO and OEB, trying to establish a framework for DER compensation and also evaluate basically existing DER compensation mechanisms. And we put out a report on the subject last year, so I'll leverage some of our findings from that report, but there's a lot more in that report that you may want to look into. And I will also planting the seeds for this work that we are now doing with Clean Energy Canada, which is going to emphasize the importance of leveraging DERs for distribution system needs. But let's just maybe talk very briefly about United States experience. As of 2025, Department of Energy estimated the US VPP potential of 80 to 160 gigawatts of capacity by 2030. What this corresponds to is that 10 to 20% of peak as of 2030 could be addressed by the VPP resources. So this is the potential. But today, demand response and traditional demand response and load flexibility stays still the backbone of flexible capacity at about 6.5% of US peak demand in 2022. With increased electrification of transportation as well as buildings, flexible electrification in the form of managed EV charging and control of electrified water heaters represent a major emerging source of dispatchable flexible demand. And last but not least, distributed battery storage is scaling very quickly, estimated at 12 gigawatts through 2028. So there's just a lot of momentum right now, especially with large loads and data centers wanting to get really quickly connected and not being able to build those generation and transmission investments as quickly as those data centers want them to. DRs are also emerging yet another important resource to be able to help bridge that gap. And in the United States, currently the common models to enable DR participation are retail rates and tariffs. Pricing is a very effective signal for DERs to show up and where to show up and which kind of services to provide. There are a lot of robust utility programs. These are demand programs, bring your own device battery programs, managed EV charging, and targeted non-wires procurements. There are also a lot of aggregators aggregating small customer storage systems and other demand response capabilities, and basically bid these into ISOs and RTOs markets to earn capacity revenues and energy revenues. So this is happening quite robustly in the United States. And last but not least, there's avenues for wholesale market participation via ISO and RTO rules, and FERC Order 2022 has been a big step towards figuring out the coordination between ISOs and RTOs and utilities, but there's definitely a lot of room for progress in that area. So this, again, very quick snapshot of where US is. But as I mentioned, been looking at Ontario quite intensively over the past couple of years, and Ontario is expected to grow significantly due to electrification, other evolving technologies in the next 25 years. The compound annual growth rate is predicted at 2.2% through 2050, and the peak growth is predicted at roughly 2% again through 2050. And ISO, the independent system operator of Ontario, is planning to build a significant amount of generation and supply infrastructure. However, they're also investing quite heavily into electricity demand side management programs that they've committed 10.9 billion through 2037 to invest in these DERs so that the pace of this load growth can be mitigated. And these are programs like energy efficiency, demand response, behind the meter solar and storage programs, and targeted beneficial electrification. And Catherine has already done a great job of covering this, but the hope and expectation is that these DERs will help reduce system peak. They enable integration of renewable resources through creating flexibility in the system. And when placed on locations with distribution and transmission constraints, that they also can help defer these wired investments. And we've recently done a projection of what is the achievable DR potential in Ontario to 2045. And we have projected that in Ontario, DRs could account for approximately 5% of the peak demand by 2035 and about 9% of the peak demand by 2045. And I should note that this is incremental to the contributions from ICI resources at this time, because these resources are already deployed during system peak hours through ICI participants' global adjustment charge reduction efforts. But if you could look at this chart on the right, you can see that in the near term, the growth is expected to come from the Ontario's trademark and really successful residential and small commercial smart thermostat program and other commercial HVAC DR opportunities, while managed EV charging is going to expand rapidly in the 2030s. And that's a function of EV projections to first increase so that there will be opportunities to manage the charging of that load. And battery storage is showing up as a small sliver of this potential, and that's kind of due to the limited customer base that has adopted at this time. So that there's a lot of variability associated with that potential. And if the market structures accommodate more and smaller systems, as well as compensation mechanisms become more stacked, that BTM storage number can be a lot higher than what we show here. But essentially, the bottom line here is that DRs can become a very material and scalable resource in Ontario, especially when supported with compensation mechanisms that would allow these resources to stack value. And what I mean by stack value is a given DR resource can provide a lot of different values. It could be avoided generation and transmission investments, or it could be avoided distribution investments, and it could be avoided energy. So that whole stack of value, if you can allow customers to stack that and get compensated for each of those elements, then they would be more incentivized to participate in different opportunities. As I mentioned at the beginning, in our report for ISO and the OEB, we built a framework to assess and establish efficient DR compensation mechanisms. And we use this framework to evaluate Ontario's existing DR compensation mechanisms, which can essentially be grouped into three buckets. There are these price-based mechanisms, and these are things like ICI, interruptible rate pilot, HOPE pricing, and all other forms of tariffs and pricing mechanisms. And there are these others which are in the procurement and wholesale market mechanisms bucket. And these are capacity auction, energy markets, expedited medium and long-term resource acquisitions and contracts. And the third bucket is the programmatic mechanisms. And these are essentially the programs designed by mostly ISO today, but also LDCs to offer programs for energy efficiency, demand response, and a whole other area of demand response capabilities or DER capabilities. And we have found that availability of alternative participation pathways for customers as well as value aligned compensation are essential to realize the potential of DERs to bring these values to the system. And, again, as I mentioned, these recommendations are discussed in great detail in our report, but for price-based mechanisms, our key recommendation is to allocate global adjustment costs to all customer types more efficiently, so that it will create more appropriate price signals for DER adoption and dispatch. On the procurement and wholesale market mechanism side, the big gap and need is the continued integration of DERs into the wholesale procurement mechanisms. Currently, ISO allows resources greater than 1 megawatts to participate in its capacity auctions and procurement mechanisms. And they are essentially working on the idea of reducing that threshold to allow smaller DERs, either in the form of aggregations or individual contributions to participate in its different markets. And the programmatic mechanisms, these are really interesting in the sense that, if the rates and market mechanisms and procurement doesn't convey all the underlying costs and provide all the efficient signals, then you could really address those gaps through programmatic mechanisms. And in fact, some customers will always prefer participation in these programs instead of going through the market mechanism. So it's really important to create well streamlined programs that are easy to participate, as well as that allows that stacking of the value and making it easy for customers to just really participate and provide their value. For the purposes of managing time, these next three slides were really going into the details of our recommendations on each of those three areas. But again, these are detailed in the report. What I'll do is I'll skip to my last slide, which is, again, I'm putting a plug for our study that is forthcoming with CEC. So as we did our work for OEB and ISO, we realized that DERs were still very robustly and widely utilized in Ontario, but they were mostly utilized to reduce the system peak, and they weren't widely utilized for managing distribution constraints. And so this was clearly a gap. And even though OEB is currently working on a lot of initiatives to, for the LDCs to establish non-virus alternatives and cost effectiveness tests and things of that nature, the uptake has been slow at this time. And we hypothesize that this may be due to not fully exploring or understanding or appreciating the distribution system value of DERs. And, that was our thinking, and the Clean Energy Canada had the same idea. So we basically have come up with the scope and the study, which is going to address this gap, hopefully, and demonstrate the potential distribution grid deferral value of DERs in Ontario. And we were able to partner with Essex Power Line System, who was able to give us actual distribution system data for 11 feeders. And we've used our internal defer model to model the expected load forecast for these 11 feeders for the next 10 years. We've established some growth trajectories, and then we built some DER portfolios. And by using our optimization model, we found a mix of DER resources that would allow the deferral of some of the upgrade needs in these feeders. and figured out the optimal number of years for deferral given the cost of these DERs. So it's really neat to understand, okay, you have to incur costs to activate these DERs, but you're really avoiding, not completely avoiding, but deferring some large investments for considerable number of years. And that really means you're retaining the time value of money, and that adds up to quite significant amounts of ratepayer funds that do not get spent. And in the era of affordability and all the inflationary pressures, it's really important to leverage these DERs for distribution grid needs as well. So stay tuned for that study. We're hoping to release that study in about a month, and I'm sure Clean Energy Canada will do more outreach to distribute and disseminate the results of that study. But let me pause here, and then I'm sure we'll have more conversation in the Q&A.
Thank you so much, Sanam. Lastly, going to go to Alex Hill, who's a partner at Dunsky Energy and Climate Advisors. Who's going to give us a bit of a presentation around some work that we've done with them on looking at the BC DER potential opportunity province-wide in British Columbia. Alex, over to you.
Great, thank you, Evan. So as Evan mentioned, I'm going to present the findings from our DER potential assessment that we conducted for Clean Energy Canada for the province of British Columbia. Quickly, I'll just introduce Dunsky. Excuse me. So Dunsky is a Canadian consulting firm specialized in providing analysis and strategy to support the clean energy transition. And of course, DERs are a key element to support the clean energy transition and part of it. So I'll get into a little bit of why DERs. My fellow panelists have talked a fair bit about these needs as well. As we increase electrification and new large loads such as data centers and bidirectional flow of energy through net metering, there's increasing needs to supply power and capacity and also to other grid services that is well suited to DERs and load flexible DERs in particular. So they can be beneficial to meet system needs. They can provide cost-effective, quick deploy, right-sized solutions, and they can be empowering to customers to generate buy-in. Going back a few years, DERs were one among many cost-effective solutions, but more and more working with utilities, we're getting to the point where they're really the cost-effective solution that's available in the short term. The alternatives related to increasing generation capacity and investing in transmission distribution infrastructure, are experiencing increasing costs, significantly increasing costs and significant schedule delays. Whereas DERs are scalable, they're modular, and can be implemented across the utility system. So they are becoming really the go-to solution, but they're not without their own barriers. So what's holding DERs back traditionally has been, they haven't been considered as part of the planning process for a lot of utilities. They haven't been fully valued. Again, my fellow panelists have covered some of these specifics in their cases. So they've been fully valued for the services they deliver and for the giving compensation to DER providers. And they're not necessarily coordinated across the system. So this study, the intent was to look at British Columbia's DER framework and context, and really to quantify if these barriers were reduced and removed, what is the potential for DERs in that market. So a little background on where Canadian utilities and system operators are at. They are currently integrating DERs more and more into utility programs and planning. They're enabling participation through procurement market rules, and they are trying to understand DER reliability and system value. There is, I think, significant concern over what is the reliability of DERs, given that they're a distributed resource, and there is, some sort of probability risk associated with them that the utilities are coming to terms with. And another challenge that we face in Canada is that so much of the background on DERs comes from the United States. And we have a very different electric systems. Many provinces in Canada are winter peaking, whereas most in the US, almost all in the US, are summer peaking. And so the context for load flexibility of DERs in Canada is very different. And it's very difficult to bring that knowledge and apply it in the Canadian context. So we need to really be developing our own solutions and our own strategies based on how the utility needs. And actually, as we do this, we can be tracking the path forward for much of North America as increasing electrification in other jurisdictions starts to lead them to become either dual peaking or winter peaking themselves, including Ontario, which will eventually become winter peaking according to projections. So we've had some good success in a few places. Hydro-Quebec is achieving in the order of 5.5% of peak demand from its load flexibility strategies. The ISO is projecting to approach a similar range, and many utilities across Canada are planning DER roadmaps, regulatory updates, and so forth. So if we look at BC in particular, BC has been applying load flexibility strategies within its programming for a little less than a decade, and achieved to this date already 1% of peak capacity savings are coming from DERs, predominantly demand response programs. And they're projecting and targeting to get that to double that by 2030. So that's in 3 or 4 years. So they're taking a very significant investment in this direction. So when we looked at the market, skipping the study overview, our objective was to identify what are the technically feasible DERs that they can be pursuing, quantify the technical, economic, and achievable potentials for DERs over the coming 15-year period, and assess the impact of demand growth and policy support for DER potential through the analysis. There are some limitations. We did look at this from a demand side perspective, and we really did focus on the peak demand benefits that DERs offer. And as a result, we didn't necessarily capture all of the value that DERs can generate. And we weren't also able to fully capture the impact of DERs over the full year. We really focused on the peak day and the ability for DERs to deliver at that moment. And we'll talk a little bit about the implications to the study, or I'll talk a bit about that as I share some of the findings. So we assessed 5 different customer segments representing different load shapes, different equipment mixes, and different DER applications. We looked at, as I mentioned, a 15-year horizon, which largely aligns with BC Hydro's long-term planning horizon. And we covered a broad range of DERs, both including ones that are very much available and common in the marketplace now, as well as ones that are emerging, including solutions such as vehicle-to-grid and vehicle-to-building, bi-directional charging. And also, we looked at solar paired with storage. We'd actually conducted a solar potential analysis for BC Hydro, and we leveraged, with their permission, those findings to understand the impact that solar PV, net metered solar PV, will have on the load curve, and then looked at how pairing storage with that can help as DER or VPP type solution to address the load curve challenges that may arise. We looked at 3 different scenarios. The first is the reference scenario, which is essentially just projecting forward the current policies and programs as they exist in British Columbia under the most, sort of the expected business as usual load growth in the province. We then also considered an accelerated DER scenario, which accounted for a faster rate of load growth, which of course leads to more opportunities for DERs to interact with end-use equipment to deliver load flexibility services. And then the third scenario, we took that high load growth scenario and we coupled it with much more aggressive and ambitious policies and investments, and to do what we call a DER-centric scenario, which really says if you look forward under a high load growth scenario, what would be the potential if DERs were really the go-to solution across the board and really maximized in every opportunity that we could identify. Sorry, skipping slide. So we assessed the technical, economic, achievable, and the effective impact of DERs across the network. So under the technical and economic potential, we really looked at what is the quantity of controllable loads on the system, and then screened which ones would be cost effective to control through a DER strategy. Under the achievable, we both looked at the adoption of DER technologies, but also the likelihood that customers with a DER technology would participate in a utility program. So for instance, you may have smart thermostat, that's an adoption question, but whether you choose to sign up for a demand response program to control your electric heater through that smart thermostat, that's a participation question. We looked at both of those. And then what we did was we also dug into saying, well, when you consider the shape of the load curve over the year and on the peak day, particularly the peak day in this case, not all of the potential necessarily leads directly to a one-to-one reduction in that peak day load curve, and we'll show some curves to demonstrate this in a minute. But essentially, what we do is come up with what is referred to as the effective carrying capacity of the DERs on the system, which is a derating factor to account for how their effectiveness diminishes as the penetration increases. We applied the utility cost test, which is the standard in British Columbia, to assess the cost effectiveness of the DER resources. And we looked at the DER value stack, but we focused, as I mentioned, we focused entirely on the capacity benefits. But as you can see from this illustrative bar chart on the right, there are other benefits that DERs can provide through deeper analysis, such as energy, line losses, price effects, and risk prevention, along with ancillary services such as voltage regulation and so forth. So those would be additional benefits that the DERs could provide beyond what we assessed. So what were the results? So the first and quite interesting result was that the technical and economic potential essentially completely aligned. In the most recent integrated resource plan from BC Hydro has a very high avoided cost of capacity in the order of, I think, $410 per kilowatt. And as a result, pretty much all the measures that we quantified in all the markets that we applied them to passed the cost effectiveness testing. Now, that doesn't necessarily mean that translates directly into achievable potential, but what it means is that the cost to the utility system isn't the limiting factor for those DERs on the BC Hydro grid. When we get to the achievable scenarios, you can see that there was significant growth from the reference to the accelerated and to the DER-centric. But in each case, there were really three measures that predominantly dominated the potential. One is EV load management, including V2X, we call it, as vehicle to building, vehicle to grid, and essentially using vehicles as batteries, which is an emerging opportunity as more and more vehicles have that capability, and there are more and more electric vehicles on the grid. It's anticipated that programs will be forthcoming. Commercial and institutional and industrial curtailment, so large customers curtailing their own loads. In some cases, that can be shutting down lights or unnecessary HVAC services within a building, or in the industrial context, it can be shutting down production. And then we also found a great deal of potential for solar-paired storage. There's significant net metering market growth in British Columbia, and by pairing it with storage, it creates a flexible resource. So the growth from reference scenario to accelerated scenario increased the DER potentials. It was primarily related to the electric end uses. So it was the same mix of measures. But when we moved from accelerated to DER-centric, we found that the increased incentives and policies that drove solar paired storage to become the top measure. And also substantial growth in residential water heater flows. We introduced a new policy in the DER-centric to assume that the province would enact an equipment standard requiring that all electric water heaters would be load flexibility enabled, starting early in the study, and then applied an opt-out type program through BC Hydro's demand response program to that. So we found quite a lot of potential available from that highly flexible resource, because of course, water heaters are an interesting mix of energy storage and hot water delivery. So I was mentioning before the effective peak load impacts. And so this is a comparison of the load curves under each of the three different scenarios on the peak day. Just to point out, this is the hour by hour peak load on the system, and then the colored line represents the load curve when adjusted for the effect of the DERs on the system. And I'll just point out that the evening is on the left and the morning is on the right. And the reason that we flipped the order is because the most interesting interaction, particularly when you look at the DER-centric, is the shifting of EV charging loads from that evening period into the nighttime load, along with some of the other end uses, which has the evening load sort of interacting with the early portion of the morning peak as well. So we thought this was more illustrative. I'll also point out that I mentioned earlier, one of the winter peaking utilities like BC Hydro and BC systems in general have a different behavior than summer peaking. And one of the key differences in the behavior is that they have dual peaks. As you can see, there's both a morning and an evening peak, typically driven by heating loads, but even though more and more is driven also by electric vehicle charging as well. So when you essentially take the difference between the pre-DER curve and the resulting adjusted curve, that's when and then we take the ratio of that megawatt delta on the system compared to the achievable megawatts of DERs enrolled in the programs. That's when how we come up with the effective load carrying capacity. So as I mentioned, it's just a derating factor. So as we get more and more penetration of DERs in the system, we do find that derating drops, drops down to 59% from around 90%. And I would point out that this is from the perspective only of looking at the peak day. If you extend that over a full hour by hour yearly load curve, you may find that there are other factors such as prolonged periods of renewable droughts, perhaps if there's lack of wind on the system, or solar is diminished due to particularly cloudy conditions. So those would be adjusted over a yearly assessment for a deeper analysis. But for the sake of ours, we found a pretty significant drop in the effective capacity as the penetration goes up, but still staying within the cost effectiveness limits. So we actually compared the costs of the programs to procure and deliver the DERs compared to the benefits they deliver. And so on the graph on the right, you can see the dark bars represent the program costs, and the lighter blue bars represent the benefits. And in all three scenarios at all three time slices, the benefits exceed the costs. Under the DER-centric, of course, it's much closer, whereas under the accelerated and the reference scenarios, it's almost 2 times the benefits relative to the costs, which indicates that there's a lot of benefit to the utility there and a lot of potential that can be exploited. But it also suggests that there's room for the utilities to increase the incentives, increase the compensation to the customers in order to go after more of the potential and move closer up to the DER-centric. And as I've mentioned before, we were looking at this entirely from a peak load reduction perspective, and there are other benefits such as the voltage regulation and energy arbitrage and even the locational benefits with non-water alternatives that DERs can further contribute to that may help to push that potential more up towards that DER-centric scenario. So the conclusion, in general, BC Hydro is on a solid footing for expanding its DER contributions. Our reference scenario largely aligned with what their projections are in their integrated resources plan through 2030. They themselves are planning a significant growth as well. The avoided costs for capacity have risen substantially just in the last iteration. In fact, this came out while we were in process for doing the study, and it led to a revision and a revisiting of the analysis because it was such a significant increase in the avoided cost of capacity. So it does create a real opportunity to expand DER adoption and to start thinking differently about what can be achieved. With these stronger incentives, the role of DERs in meeting BC's emerging grid needs could be transformative. We see a 90% increase in the potential compared to the accelerated scenario under the DER-centric scenario. And, it would require ambitious policies and investments, some of which would be voluntary, some of which would be requirements in the market. But this would be supportive of BC's general decarbonization efforts across the board and complementary to the electrification initiatives within the province. So, I guess the question is where can BC go from here? This was a relatively high level study, looking more closely, and there are a lot of analysis and initiatives related to non-wire alternatives going on in the province. So continuing to explore where and to what degree DERs can offset transmission and distribution infrastructure investments. Look at the grid balancing and other services that DERs can provide on the system and understand those benefits. And then also understanding better the reliability and operational integration of how DERs can function within the system and gain confidence with the reliability of the DERs themselves, and also understand over the full year, not just on the peak load day, how can DERs contribute overall to the grid reliability. And I think that wraps up my presentation.
Thank you so much, Alex. I would invite all the other panelists to turn their cameras on at this point because we'll move into a bit more of the discussion phase of this. While the cameras are coming on, just wanted to reiterate that the VPP study that we heard about first from Constanza is already available. That's been published. The Dunsky study that Alex Hill just covered was actually released on Monday, and you can see that on our website there. And as Sana mentioned, the study that's looking at the Ontario distribution value for DERs is going to be published in the next month or so. So that will be in your hands shortly. We've had a ton of questions come in, so I'm going to be jumping sort of straight into a whole bunch of different audience questions, as well as a couple that we prepared in advance. And Constanza, I actually wanted to start with you. You mentioned the need for Canada to strengthen policies and incentives, as well as creating new revenue streams as being key to unlocking that opportunity. I'm wondering if you can share any sort of key examples or key steps that you're seeing when you look across international jurisdictions and some of the leaders there that were leading the way on VPP readiness that you would highlight for Canadian jurisdictions that are looking to step up in this space.
Yeah, thank you. So I think on the policies, incentives, and revenue stream, this is fairly dependent on the specifics of each market, but we can see some trends. So first, we see in the moderate readiness package that jurisdictions are often more centered in DER adoption. So that means different type of incentives that would increase, for example, rooftop solars, EV uptake, home batteries, or electrification. This can happen through incentives to support the purchase of these assets, but it can also be through tariffs that are encouraging businesses and homes to uptake this by increasing the return on investment. So this is very specific to jurisdiction. I think Canada and different provinces already has things like this. But one of the main differences we see in markets is their configuration. We often see that liberalized markets, so that means markets that are not controlled by a single utility, for example, in Canada would be the Crown utilities, have a tendency of having more value streams that are accessible for PPPs, especially third-party PPPs or DR orchestration. And that means that in liberalized markets, you can have either capacity markets, energy markets, or ancillary services markets that are accessible for aggregators. However, we know that this is not the only ways that PPPs could participate in bundle markets or markets controlled by Crown utilities. Usually this will need to happen through programs or demand response specific solutions or non-wire alternative solution programs targeted to the specific needs of the jurisdiction. So in both type of markets, it one needs to adapt. One will have a tendency to have more third-party participation, and the one more through programs or specific bilateral contracts.
That's great. And I think especially on the last point with the number of different Crown utilities and vertically integrated ones we see in Canada, I think some really important lessons there. Sam, similar question for you. Brattle does all sorts of work across North America, a wide variety of US states. Curious what Canada and Canadian provinces can learn from some of the leaders down in the US, where you're seeing them integrating VPPs, comprehensive VPPs, but at least DERs more comprehensively into their planning and operation.
Yeah, no, thanks, Evan. I think in the US, the jurisdictions that consistently lead the way are the ones that were able to move beyond DR deployment and to operational integration and value stacking. So California is one of the most mature DER integration market. They're anchored by the CPUCs, their regulators, DER action plan, and there's a very explicit coordination of grid planning, affordability, load flexibility, market integration. So they spent a lot of time sort of putting all these pieces of the puzzle together. And it's, even though it's still work in progress, they've made great progress. I would say New York is another one. And what New York has done is that they've come up with this value stack tariff. This whole idea of, if you don't compensate DRs comprehensively for all the value that they provide, then you won't be able to incentivize those DRs to uptake those market services, and you will basically be leaving all that value on the table. So through their value stack tariff that compensate DRs based on the time and the location of the services provided, that they're able to integrate a lot of DRs to their systems. Massachusetts is doing a lot of great work in terms of proactive planning. So I don't know that this is happening yet in Canada, but with the expectations around increased electrification, and some feeders and substations are already seeing reaching the peak loading limits. So their utilities are allowed to build capacity and expectations for those loads coming up. And there's some great work going on in Colorado right now, building a lot of VPPs and trying to scale them up and taking them from these like one-off pilots to a resource that can really meet the system needs.
Moving beyond pilots, certainly keeping up with continuing to drive deployment in households and businesses, but moving to integration into planning, creation of markets, allowing these to actually be seen as resources that could compete to provide these sorts of energy services.
Absolutely. And I think one more thing that I will mention there is that the coordination and governance between the bulk grid and the distribution systems is super important. And I don't think that, again, that's still work in progress. With those of you familiar with FERC Order 2022, that's geared towards figuring out this interoperability, telemetry, coordination. If a resource is dispatched by a distribution utility, to make sure that that resource is also not committed to provide bulk grid services, because the system is really relying on these resources to deliver. So there's that coordination is going to be exceedingly important as DER penetration increases in our systems.
Thanks so much. Alex, can you take us home a little bit to Canada here? Dunsky's done lots of work in a bunch of different provinces looking at DER potential, looking at programs, looking at policies. If we're wanting to sort of step into this space more, we saw from Constanza's work that there's a wide variety of levels of ambition and success so far, and from a readiness perspective across provinces. What has Dunsky found are some of the biggest sticking points for governments when it comes to thinking about DERs, really leveraging these, and I think really importantly, moving these beyond pilots into how we plan and operate grids here in Canada?
Yeah, thanks, Evan. It's a good question. I think one of the points that we find is a consistent challenge is that many, or perhaps most, governments in Canada have not conducted a robust value of DERs, or even in some cases a value of solar study to back up their DER policies and programs. Even if we know they're technically viable, it can be difficult for governments to put forward policies or encourage programs at utilities if there's no clear understanding about just how much value they offer to the grid. And we've done work on the US side, helping a number of different parties, including state governments, develop their own value of DER frameworks, and they're extremely helpful for giving a sort of common reference point for how you're going to assess the viability of different resources. And they can be resource agnostic, like the one we developed in New Hampshire. And another issue is that there is often skepticism among the utilities about how much DERs can do to meet their system needs, based on a lack of analysis or based on past assumptions. Given that governments are not often equipped with VDR studies to back up their proposed policies, it becomes difficult to change rules and regulations. So DRs are more distributed, more probabilistic, and depend on customer behavior, third-party aggregators. Makes them feel riskier, and even when the model value is strong. And the other thing I think is that the context is changing quickly. In past studies, pilots and experience with DER may not match today's realities, where the value of avoided costs to the grid is significantly higher. New controls and connection solutions are available, and the load curves are in the process or about to be transformed by electrification. And again, I think one of the other challenges that Canadian governments and utilities face is something I mentioned during our presentations. I think that while there's some good experience in the US, a lot of it just doesn't really translate to winter peaking utility challenges. It's different measures, it's a different type of load curve. We even have different regulatory approaches and different capital use rules among our utilities. So it's not directly transferable. If anything, I actually see a future where Canada will have experiences and knowledge to share in the US that will be very valuable. And I sometimes wonder how transferable some of the knowledge is the other way at this point.
Yeah, I actually want to pick up on that. And there was a question that came in that was asking about why electric heat can be considered a core resource for a VPP when in Canada, in a lot of provinces, we're actually talking about then electrifying something that is currently, using a fuel, using oil, using natural gas, and could actually be a net source of new demand for electricity as opposed to a resource. Sano, I'm curious if you can share anything from some of the looking at where heat is coming into play, and then Alex, how that's playing into those winter peaking systems you're talking about up here in the north.
Yeah, so I mean, I think it's really a function of, I mean, at least in the US, there are all these states that have committed to really ambitious climate goals, and part of the roadmap to achieving those goals is to electrify broadly, including those buildings switching from gas heating to electric heating. So that decision and commitment was already made, and then that was kind of an era where large loads weren't there. So we were not too concerned about being able to meet the grid needs and capacity needs and whatnot. But so even with the electrification of heating, I think that to the extent that those customers are able to participate in these peak perks like smart thermostat programs, that there are ways to be able to set those thermostats like a few degrees during the system peak periods and just derive that required flexibility. So I mean, I don't know that it's an either or question, that that electrification is probably going to happen, especially with the COP coefficient of power production or the heating efficiency of the heat pumps, that they are improving and they're becoming really comparable to the heat that you could quality of heat you could get from furnaces. So that's likely to happen. I think the question for us is how to manage that efficiently through load flexibility.
Alex, anything you want to add from a Canadian specific context when we're thinking about heating and, as I said, those winter peaking systems?
Yeah, and I don't know if this is Canadian specific, but just in general around electric heating or electrification of heating, it can be a resource and it can support lower costs to electricity customers if it's coupled with load flexibility effectively, because you can just you can fill some of the troughs in the demand curve by using load flexibility to offset the heating need away from the peak, and that puts more kilowatt hours through the same poles and wires of the system, which ideally reduces the overall system maintenance costs as the part of the bill. Yeah, and certainly in Canada, I think one of the opportunities that we have with heat pumps in particular is displacing electric resistance heating, which you don't see as much in the US as we a lot of it in a number of provinces in Canada. And so heat pumps, aren't necessarily always electrification here. They can actually be a super efficiency measure, particularly cold climate heat pumps that might operate at the peak low temperature in places like British Columbia. So lots of opportunity there, I think.
Okay, thanks. I want to, just in the last 2 minutes here, I want to just shift to another topic that I know is one of the DER uses that I'm most interested in and that I think has not been Alex, I think you mentioned that there's a whole bunch of different benefits that DERs can play, and we've been talking a lot about capacity shifting. But another one is the interplay between DERs and renewables, and the opportunity to help get more out of renewable resources, which in many cases are the lowest cost way of generating electricity. One of the questions that came in, though, was about the sort of intermittency of wind and solar and the opportunities that DERs could play in helping address some of the longer term duration challenges. We've got batteries, lithium ion batteries can be 2, 4, 6 hours, but beyond that, perhaps not able to meet some of those longer windows. Where do DERs come into play? Constanza, I'd love to throw it to you first. I know Australia is actually one of the places that's been tackling this in a very real way, right at the front of the pack when it comes to everything from batteries and rooftop solar to actually grid scale battery integration there.
Yes, so Australia is one of the countries with the highest rooftop solar uptake. Around a third of households already have rooftop installed. So this has driven high benefits of like reducing cost, but especially at noon. And so the country has already started preparing and doing several assessments and programs to take into consideration this changing in the landscape when you have high variable renewable energy penetration. If you have a mix of solar and wind, some of the variability, and there can be some complementary because they will not produce at the same time. However, when you have mainly solar in your system, you're going to start having very low prices during the middle of the day. So having other DRs can greatly benefit this. So by having more batteries in the different levels of the network, not only in households but also in households, EVs, etc. You can use them as resources to shift the demand to moments where actually it's needed or they will benefit further. So having solar soaking EV tariffs could be a part of it. Encouraging the usage in the middle of the day can also work. And for batteries, getting them to join in a VPP will help aggregators or retailers that are here in Australia, the ones that are actually operating most of the VPPs, get them to use the batteries in a way that will serve the system when needed. So all of this needs a lot of coordinations, but it's true that using the different resources together can actually help to seize the benefit that was intended from one, for example, solar, when the system already starts to get to levels of integration and uptake that are high, like in Australia.
Thank you so much. And I would love to have been able to pull sentiment on that as well, because I know California has been doing all sorts of work when it comes to batteries, renewables, DERs. But unfortunately, we are at time today. Apologies if we weren't able to get to your question. Would love to receive an email from you if you didn't get your question answered and you want to follow up here. Really appreciate everyone taking their time today. Lunch hour for some, later in the afternoon for others, for joining us on this topic. We will be sending out an email afterwards, and we'll be looking to attach the different reports that were mentioned on this where they're already published, and we'll circulate the others when they become so. Wherever you are, I hope you have a wonderful rest of your day. And thank you for joining us. And thank you to our panelists one last time as well.
Thank you, Evan.
So much.
Thank you.